Okay, what if the very idea of intelligence, how we learn, has just been way too narrow?
Too small. How so?
Well, what if intelligence isn't just something that, lives inside human heads? And learning isn't limited to what happens in our brains.
Ah, right. That's a question that really gets to the heart of things, doesn't it? It
Yeah.
asks us to fundamentally rethink our place, our relationship with everything else.
Absolutely. And it's the really provocative idea behind the work we're diving into today. This is a deep dive into some truly boundary-pushing territory explored by the theorist and Katherine
Oh,
Hayles.
Hales, yeah. In her book, Bacteria to AI, Human Futures with Our Nonhuman Symbionts.
Exactly.
She's got a track record, right? Challenging how we define things like embodiment, consciousness.
Definitely.
Yeah.
And this book takes those ideas and just runs with them, looking at the future, what we're building alongside non-human things.
Okay, so to unpack this, we're looking at
We've pulled key insights from excerpts of the book itself, some interviews she's done. I think one was with the philosopher, another with Urgent Futures,
I saw this.
and other related stuff that talks about the core concepts and, maybe more importantly for you listening, the real-world implications. We're even going to touch on a specific application, smart training AI.
Got it. So the mission here is, what? To pull out the main takeaways from Hale's view. This idea that cognition isn't just us.
Yeah, that it's everywhere,
Right.
from microbes to machines, and then explore what this really means, especially for how we design things like learning, training, human development stuff today.
Okay, let's do it. Where does she start?
Well, she kicks things off arguing we urgently need to broaden how we even define cognition, and a big driver for her, the why now, is the climate crisis.
Right, that's a critical frame. She ties the climate crisis directly to anthropocentrism.
Our human-centric view.
Exactly, this, often unconscious belief that humans are top dog, the only truly smart ones, and so we have the right to control everything. She actually calls it a dangerous illusion.
Okay, so to fight that, she proposes a new way of looking at things.
She does. It's called the Integrated Cognitive Framework, or ICF. The whole point is to knock human cognition off its pedestal.
Not see it as the peak or the only valid model.
Precisely.
Yeah.
Instead, it places human thinking in relation to all the other cognitive entities out there. It kind of decentralizes the human.
So it's less like our minds are separate and above everything.
Yeah, much less.
And more like we're just one node in this huge network of knowing and doing.
That's it. It gives us a lens to see intelligence working in places we just haven't traditionally looked or haven't valued.
Okay, so that brings up the big question. What actually counts as a cognitive entity in this framework if it's not just us, not just things with brains?
Right. She gives a really clear functional definition. It's based on 5 key behaviors. She uses this handy acronym, CIRL.
CIRL. Okay, spell it out for me.
Sure. Sense, interpret, respond flexibly or creatively, anticipate, and learn.
Sense, interpret, respond, anticipate, learn. CIRL. Got it.
If something exhibits those 5 behaviors, it's cognitive according to the ICF.
And the crucial point you said earlier is this doesn't need consciousness.
Not at all. And that just blows the doors wide open,
Yeah.
right? Think about the range of things that fit. The sources mentioned bacteria, plants, fungi, animals,
Humans, obviously.
humans, of course, and importantly, artificial intelligence.
Wow. Okay, so take bacteria. A bacterium senses, like a sugar molecule, interprets it as food, responds by moving towards it, anticipates getting energy, and maybe learns the best path over time. Under CIRL, that's cognition.
Yes, that's a fundamental level of cognition playing out. Or think about a plant sensing sunlight,
Right.
interpreting where it's coming from, responding by growing towards it, anticipating more light, learning maybe which direction is consistently best. It fits.
It's fascinating. And she connects this to her earlier work, too, right? Like in Unthought, where she talked about cognition inside humans.
Yeah, that's vital. She argues that our conscious thought, the stuff we're aware of, is just the tip of the iceberg. The vast bulk of our own thinking and processing is non-conscious cognition.
So not like Freud's unconscious, built on stuff we push down.
No, totally different.
Yeah.
This is the fast, complex processing happening below awareness. It handles pattern recognition, intuition, skilled movements.
Like catching a ball without thinking about the physics, or just knowing someone's mood from their expression.
Exactly. It's faster. It handles noisy, messy input way better than our conscious logic. It's deeply tied to our bodies and senses, and this is key, evolutionarily it came first. Consciousness is built on top of this huge non-conscious foundation.
So even if we forget bacteria and AI for a moment, most of what lets us function day to day isn't even happening on our conscious radar.
Right. Completely shifts the focus from that deliberate, rational voice in our head to this much broader, faster, embodied way of processing the world.
Okay. And she draws a line between things that have this chiral capacity and other things that are just powerful forces.
Yes, that's the difference she makes between agents and actors. Agents are basically material processes.
Like a hurricane or erosion.
Exactly. A tornado, a chemical reaction, ocean currents. They have huge agency. They cause massive change,
Yeah.
but they don't interpret information or learn in the chiral sense. They're just physics playing out.
So a tornado is an agent. Powerful, but not an actor.
Correct. Actors, in her view, are the life forms and the computational media that do show chiral behaviors. They interpret info, they pursue goals, whether that's survival or programmed objectives.
So bacteria are actors, we're actors, AI systems are actors.
You got it.
Okay, so we've widened the lens on cognition beyond humans, beyond consciousness. We know who the actors are. Now, when you put these different actors together, especially humans and computational ones, things get complicated fast, right?
That's exactly where the idea of cognitive assemblages comes in. The argument is that in developed societies, we don't operate as isolated individual minds anymore. We function within these complex systems.
Systems linking humans, non-humans, computers.
Yeah, all joined together through flows of information and shared actions. And the key is that agency, the ability to make decisions and act, isn't located in one place. It's distributed across the whole assemblage.
Can you give me an example? Something every day.
Okay, think about navigating with GPS on your phone while driving.
Okay.
You got you, a human driver, an actor. You've got the GPS software, the AI interpreting satellite data and traffic feeds, another actor. You have the car itself responding to your inputs, but maybe with its own assists, semi-autonomous actor. Information flows satellite to phone, phone to you via voice map, you interpreting road signs and the AI's directions, you acting on the steering wheel.
Right. The decision of which turn to take emerges from that whole interaction. It's not just me, it's not just the app.
Exactly. The intelligence of that navigation system is distributed. It's more than the sum of its parts.
Okay, I get that. And this entanglement, especially between us and computers, is getting really, really deep now. She calls it
Technosymbiosis.
technosymbiosis, like biological symbiosis, but with tech.
That's the analogy. Just like we depend on our gut bacteria for digestion, Hayles argues our interdependence with computational media is becoming just as fundamental, just as profound.
And there was that really jarring statistic you mentioned from the sources.
Yeah, it's a real wake-up call. Hayles speculates, and it is speculation, but thought-provoking, that if all computational media just vanished overnight, poof,
Yeah.
maybe only 10% of the global population would survive 6 months later.
Wow. Only 10%. That's staggering. It really drives home how much our food, water, energy, communication, transport, everything relies on this digital layer.
It's not just a convenience anymore, is it? It's basic survival infrastructure for most of the planet.
Makes technosymbiosis sound less like a metaphor and more like a literal description.
And it's not static, this dependence. It's dynamic.
Dynamic how? Co-evolving.
Exactly. It's a co-adaptive relationship. Humans shape technology, and technology shapes us constantly. And this interaction is now so intense and rapid, she argues it's creating what she calls second-order emergences.
Okay, second-order emergences. What makes them second-order, and why accelerated?
Well, think of maybe first-order emergence as things arising within one domain, like, say, complex life from simpler biology through evolution. Second order, in Hayles' view, happens when three really fundamental scales or domains get tangled up and interact. Micro.
Like quantum stuff, subatomic.
Yeah, the smallest scales. Then evo.
Biological evolution.
Right. And techno, which is technology, tools, but also human culture, knowledge.
Micro, evo, techno. And when they tangle, things speed up. New stuff appears faster.
Yes, their entanglement creates phenomena that just couldn't happen or happen nearly as quickly within any one domain alone. The classic example given is gene editing, like CRISPR.
How does that fit?
Well, it requires understanding biological evolution, evo, manipulating molecules with incredible precision, almost down to the quantum level, micro, and using sophisticated technology and accumulated human scientific knowledge, techno. The ability to rapidly rewrite life itself emerges from mixing all three.
Got it. And the current landscape with AI becoming so capable and integrated everywhere feels like the techno part is just exploding.
Absolutely. Hayles really emphasizes this point. The capabilities we have now with AI, especially large language models, deep learning, It's historically unprecedented. We're in totally uncharted waters in terms of the speed and depth of this technosymbiosis.
Okay, let's focus on AI then, since it's half the book title. Can AI, like these LLMs, actually create meaning in this framework? That really pushes back on the idea they're just fancy prediction machines, stochastic parrots.
She argues, yes, they definitely can and do create meaning, and she challenges that parrot idea by explaining how they do it. It's not just predicting the next word based on frequency. They're building these incredibly complex networks of correlations between billions of bits of text, these tokens.
Correlations that act like analogies or recognizing relationships.
Precisely. Remember that example of mapping GPT-2 neurons, where specific neurons fired up to represent the relationship between king and queen in the way that mirrored man and woman?
Right, yeah.
That shows the AI isn't just mimicking. It's identifying and structuring meaningful relationships within the language itself. By building these vast, intricate webs of meaning from text, they can generate output that feels genuinely meaningful to us and is often indistinguishable from human writing.
Okay, so they operate on meaning. But is their experience of that meaning anything like ours? Can it be?
That's where the concept of Umwelt comes in. It's a term from the biologist Jacob von Uexküll.
Welt, meaning like world horizon.
Yeah, basically the unique perceptual world of a species, shaped by its senses and its way of thinking. Your dog's Umwelt is dominated by smell in a way ours just isn't.
Right.
And AI, particularly LLMs, have a radically different Umwelt from ours. It's entirely constructed from data, text, images, code. It has no body.
No physical interaction with the world. It doesn't know what heavy feels like or cold or sweet.
Exactly. Its understanding of language, even concepts like heavy, is derived purely from statistical patterns in how words are used together in the data. It's not grounded in physical sensation or real-world interaction. That's a profound difference.
And this difference leads to a distinction she makes about creativity, about different kinds of innovation.
Yes. She distinguishes between possibility and potentiality. AI, she says, is incredibly powerful at exploring the realm of possibility.
Meaning what's possible within the existing data.
Right. Give it a massive data set, and it can find connections, spot patterns, generate novel combinations of existing ideas or elements far beyond human capacity, just due to sheer speed and scale.
Like finding a new drug interaction by analyzing millions of patient records.
Exactly.
Yeah.
It's exploring the landscape of what's already known or implicitly present in the data and making new links within that space. Potentiality, though, she suggests, is different.
Right.
Potentiality is the human knack for envisioning something truly new, something that doesn't just rearrange the existing pieces, but creates a whole new framework, a conceptual leap.
Like Einstein's relativity wasn't just combining old physics formulas in a new way.
Precisely. It was a radical rethinking that opened up a whole new space of possibility that didn't exist before. Hayles argues this capacity for potentiality, for generating genuinely unprecedented ideas, is, for now at least, uniquely human.
So is there a worry then? If AI generates more and more text, images, code, and that output gets fed back into training the next generation of AI, could we get stuck?
That's the concern about the recursive loop. If the training data becomes increasingly dominated by machine-generated content, you might see a kind of homogenization.
Like an echo chamber.
Sort of. A reinforcing of existing patterns, potentially crowding out the diverse, messy, sometimes unexpected human inputs that might spark that leap into potentiality.
Does Hayles have a take on the big question? Could AI ever become conscious?
She doesn't dismiss it, which is interesting. But she suggests that for AI to gain consciousness, actual self-awareness, subjective experience, it would probably need totally different hardware, not the silicon chips we use now.
Something more like a brain. Biomorphic.
Yeah, maybe something like the neuromorphic chips, like synapse, that try to mimic brain structures.
Yeah.
But the really critical point she makes is, if an AI did become conscious, we'd suddenly face enormous ethical responsibilities towards it. We couldn't just treat it as a tool anymore.
Right. Okay, so we've gone from bacteria to AI, expanded cognition, technosymbiosis, cognitive assemblages, possibility versus potentiality. Let's bring this down to earth. What does all this mean practically for people in learning and development? Training, coaching, workplace learning.
Yeah, this is where it gets really actionable. It's basically a wake-up call, suggesting that a lot of our traditional learning models are built on those old, human-only, conscious mind-only assumptions.
Assuming learning is just pouring information into someone's head in a classroom and they consciously absorb it.
Pretty much. But if cognition is distributed, if a lot of it is non-conscious, if we learn within these assemblages with technology,
Yeah.
then that old model is missing a huge part of the picture. How do you design learning for that reality?
And this is where you see something like smart training AI fitting in as a practical example.
Yes, exactly. From the descriptions, smart training AI seems to actively try and embody some of these ideas. It's applying this expanded view of cognition and leveraging technosymbiosis specifically to improve learning.
How does it tap into that non-conscious cognition piece?
Well, it seems to go beyond just asking people, how do you like to learn? It uses real-time profiling, looking at how someone is actually interacting, maybe their pace, their error patterns, their preference for visual versus text as they do it. It tries to get at the cognitive system's needs.
Which might be different from what the person consciously thinks they need.
Right. It aims to adapt the delivery based on how the learner's brain is actually processing the information, tapping into those faster, non-conscious preferences and bottlenecks. It makes the learning responsive to the underlying cognition.
And the cognitive assemblage part, how does it fit there?
It literally creates one. You have the AI system, the human trainer, and the human learner all interacting. The AI isn't designed to replace the trainer.
It's augmenting them, giving them superpowers.
That's the idea. It acts as this intelligence layer, feeding the trainer real-time insights and suggestions based on the learner's cognitive state and profile. So the trainer, armed with this AI partner, can adjust their approach on the fly. The whole system trainer plus AI plus learner becomes a smarter cognitive assemblage focused on learning.
So it's technosymbiosis, but specifically for training.
Yes, it looks like a clear example. Humans, trainer and learner, and computational media, the AI platform, in a co-adaptive loop. The AI's tools like the learning style assessment, the adapt-the-nature. Your training features provide guidance grounded in neuroscience, helping the trainer tailor delivery based on the learner's unique cognitive needs. The system adapts based on the interaction.
And the results they claim are pretty striking.
Yeah, the sources mention significant improvements, up to 88% better outcomes compared to traditional methods, higher engagement, people applying skills faster. That directly tackles the big challenge for L&D folks and trainers. How do you prove real impact? How do you make learning stick? How do you differentiate yourself beyond just running sessions?
It sounds like moving towards a learning design that isn't just human-centric, but cognition-centric.
That's a good way to put it, a post-anthropocentric learning approach. It uses our understanding of distributed cognition and builds these symbiotic systems where AI helps make learning truly adaptive, personal, brain-aware, aligning it with how we actually learn in all its complexity.
Wow. This deep dive into Hayles' bacteria to AI really does force a huge perspective shift, doesn't it? Moving away from seeing our conscious thought as the pinnacle.
And instead, recognizing cognition as this incredibly broad, distributed spectrum. It involves microbes, plants, animals, us, machines, operating through non-conscious processes, all tangled up in these deep, co-evolving technosymbiotic relationships.
And why is getting our heads around this so important right now?
Well, on one level, challenging our anthropocentrism might be crucial for tackling planetary risks, like the climate crisis she mentioned. But more immediately, it gives us a framework to fundamentally redesign how we approach learning, training, development, making it far more effective, engaging, and actually suited to how cognition works in this complex, interconnected world.
It completely changes the game. So if we really are living in this world of distributed cognition, this deep technosymbiosis, here's maybe a final thought for you to chew on. How does this shift our personal responsibility? Not just for what we decide to learn, but for how we choose to interact with and build with and learn alongside all these different cognitive entities, the biological ones, the artificial ones that share this planet with us as we try to navigate whatever